Hey guys, in this video we are going to be talking about solving systems of linear equations by a method called linear combination, or you may have also heard it called elimination. They are the same. And so let's go ahead and do our first example. In this first example, we have 2x plus y is equal to 6 and x minus y is equal to 3. The first step we want to make sure to do is find matching terms between both of my equations. Now, when I talk about matching terms, the sign itself does not matter. What does matter, however, is that the leading coefficients are the same, irrespective of their sign, and the variable attached is the same. So, for example, in our two equations, our variable is both y, and their leading coefficients are 1 and -1. Like I said, the sign does not matter, so we do have a pair of matching terms. Now, with that being said, once we have that matching term, or those matching terms, we can either add or subtract to eliminate one of the variables. And specifically, the variable we're interested in eliminating is the variable that is a part of our matching terms. So in this case, we're going to be eliminating the y term from our equation. So I'm going to rewrite our equations. 2x plus y is equal to 6, and x minus y is equal to 3. So the question is, how can I get rid of this matching pair? By addition or subtraction? Well, I'm hoping you can see this, but if not, let's do it separately. So you have a positive y, some operation, it has to be either addition or subtraction, minus y has to be equal to 0. That is our goal. How would I get rid of them? Well, I'm hoping that you can see this, that if I add y plus a negative y, I will end up with y minus y, which is indeed equal to 0. So what that tells me then is I need to add the entire bottom equation to the top equation so that I can get rid of that y variable. So I'm going to add, okay? So here we go. 2x, and remember we have to add like terms. So 2x plus x is 3x. Positive y plus a negative y is going to be 0. And that is equal to 6 plus 3, which is 9. Now we're going to go ahead and solve for our variable x by dividing by 3 on both sides, because the operation between the 3 and the x is multiplication. Okay, so we end up with x is equal to 3. Once we have this solution for our first variable, or our x, we can go ahead and substitute this answer into either of the original equations. So I'm going to choose to substitute it into our second equation, which is x minus y is equal to 3. But instead of x, I'm going to put 3 because that's the solution we have found. So 3 minus y is equal to 3. And when I solve for y, I will end up with y is equal to 0. Okay? Now in order to check it, you can simply substitute these two answers, x equals 3 and y equals 0, into the first two equations. So is 2 times x, which is 3, plus y, which is 0, equal to 6. Is that the case? Well, 3 times 2 is 6, plus 0 is simply 6, and that is equal to 6. So that's correct. And in our second equation, x, which is 3, minus y, which is 0, is that equal to 3? Well, yes, it is. So this is our solution, or these are our solutions to our system of linear equations. Let's take a look at another example. In this example, we have a system of linear equations. However, what you would take notice of is that we don't have a matching set or matching pair, because our variables do not have the same leading coefficient irrespective of its sign. So with that being said, we have to manipulate one of these equations so that we can get a matching pair. So if you take a look at our equations that we have, there's many ways you can go ahead and manipulate this set of equations. But I'm going to look specifically at the 3x and the x. How can I make them match? Well, if I multiply this x by 3, I can end up with 3x. However, I can't just multiply that x by 3. I have to then multiply the entire equation here by that 3 in order to keep the relationship that is between these two equations true. So if I need to multiply the x by 3 to get that 3x and get a matching pair, then I need to multiply the entire equation by that same number. So let's go ahead and do that. So I'm going to rewrite the first equation, 3x plus 2y is equal to 46. And I'm going to multiply the entire bottom equation by 3. And I'm left with 3x plus 15y is equal to 33. Now that I have this matching pair, the question then is, what do I do, add or subtract, that will help me to get rid of it? Well, 3x minus 3x is 0, so I can subtract the entire bottom equation from the top equation in order to get rid of that first pair, or that matching pair. So 3x minus 3x is 0. 2y minus 15y is negative 13y. And that is going to be equal to 46 minus 33, which is 13. Now let's go ahead and solve for y. We're going to divide both sides by negative 13 because negative 13 is what's being multiplied by y, and that's what we want to get rid of. So when I do that, y is equal to negative 1. Now that I have that solution for y, I'm going to substitute this into one of my original equations. And I'm going to choose to substitute it into the second equation. You can choose the first one if you wish, but I'm going to choose the second. So I have x plus 5y is equal to 11. Now instead of y, we're going to put negative 1. So x plus 5 times negative 1 is equal to 11. X minus 5 is equal to 11. And we're going to add 5 to both sides to get rid of the 5 on the left-hand side. And so x is equal to 16. Now you can go ahead and substitute these two answers in, y is equal to 1, x is equal to 16, into both of your equations, the original equations here, and see if it is true to make sure that your solutions are exactly what they're supposed to be. Or if they are not, or if it does not make your equations true, then you may have done something wrong in the process of solving, or in this step-by-step process of the elimination. So let's go ahead and look at a final example. In our final example, we have our system of linear equations. Now, I want you to take a look at what you're seeing. The first step we said was to see if we have a matching pair. Well, we don't have a matching pair. In other words, the coefficient that is attached to the x variables are not the same, and the coefficients that are attached to the y variables are not the same. Not only is that the case, but there's no one whole number that I can multiply our leading coefficients by to match it with the other coefficient. So for example, what whole number can I multiply 3 by to get 2? Well, there is none. Or what whole number can I multiply 2 by to get 3? There's none that I know of. Similarly, there's no whole number that I can multiply 6 by to get 7, or 7 by to get 6. So with this particular example, I have to multiply both of my equations by two different numbers so I can get a matching pair. Now, the numbers I'm choosing to work with, or the pair, the variable that I'm choosing to work with is the x variable here. There is a way for me to manipulate both of these numbers or these terms so they can be matching, or they can match. If I multiply the 2x by 3, it becomes 6. And if I multiply the 3x By 2, it becomes 6x. And so therefore, they would be matching. Now, with that being said, because I already know what number I need to multiply these terms by so that they can match, that same number I need to multiply the entire equation by so that I can keep that relationship true between the two equations. So the entire top equation I'm going to multiply by 3, and the entire bottom equation I'm going to multiply by 2. So the first equation, I end up with 6x plus 18y is equal to 12. In our second equation, which I've multiplied by 2, I get 6x minus 14y is equal to 12. Now, I do have matching terms, 6x and 6x. Now the question is, how will I get rid of that term or those two terms? Well, if I subtract 6x from 6x, I can get 0, which will help me to accomplish my goal. So I have to subtract the entire bottom equation from the top equation. Now remember, I have to combine the like terms one at a time. So 6x minus 6x is 0. Positive 18y minus a negative 14y is the same as saying 18y plus 14y, and that's going to be 32y, and that is equal to 12 minus 12, which is 0. Now we're going to divide both sides by the 32, and we'll end up with y is equal to 0. Now we're going to substitute this value into any of our two original equations. I'm going to choose the top equation, or the first one, which was 2x plus 6 times y, which is 0, is equal to 4. Now let's go ahead and solve for our x. 2x is equal to 4 because 6 times 0 is simply 0. And we're going to divide both sides by 2, and x is equal to 2. Now you can go ahead and check your solutions to see if they're true. I'll check one of them. 2 times x, which is 2, plus 6 times y, which is 0, is that equal to 4? Well, 2 times 2 is 4, plus 6 times 0 is 0, and that is absolutely equal to 4, so that is true. You can go ahead and check the second equation, and this is how you would apply linear combinations or eliminations to a system of linear equations.